Well, good afternoon. Welcome back for our professional development session. And we're going to have a change of pace here. You can see we're sitting. And we're also going to, so let me give you a little bit of an idea of what's going to happen this afternoon. We're going to have a conversation for about 30 minutes. And then we're going to have a interactive group discussion activity, and we'll hope that some of you will share with the room. And then after that, we'll have a question-answer session. So I hope you will, bring your questions. I hope you'll be excited about, bring your burning questions and just, dive in and talk about the things that, you want to talk about here. To start off, I want to introduce myself. As all of you already probably recognize already, my name is Sarah Webb. I am Krell's science media editor. What does that really mean? I write the magazine articles that you see. I write for our websites. I do some social media. I host a computational science podcast, and I do things like this. So here I am. Science communicators get into doing this a lot of different ways. I am a chemistry PhD, so I got into this basically straight out of graduate school. I started sort of changing careers while I was finishing my degree. So if you're wondering a little bit about kind of my perspective and where I'm coming from as an interviewer and as a communicator, that's where I am, and that's my background. And in today's session, we're going to be focusing on the importance of narrative in creating rich science communication. And our speaker and expert today is Dr. Emma Frances Bloomfield of the University of Nevada, Las Vegas. And she's going to be guiding us on this journey to learn these tools. And so I told you about the 3 parts of our session. And so we're going to start with this interview portion. And before Emma starts talking about her book, I want to actually tell you a little bit about Emma and the book itself. So Dr. Emma Frances Bloomfield is an associate professor of communication studies at UNLV. She completed her PhD in communication at the University of Southern California and is a rhetorician interested in scientific controversies, environmental communication, and the interactions of identity, ideologies, and storytelling. Her primary area of study is climate change communication and the obstacles to and opportunities for environmental conversations. She is the founder and co-director of Greenspun College's Public Communication Initiative, which conducts original research and hosts workshops on communication strategies. She teaches classes on rhetoric and persuasion and is an advocate of inclusive pedagogy. Welcome, Emma.
Thank you. Thank you for having me. It's really a pleasure to be here. I got to catch a few of the talks after lunch, and I'm just really excited to engage with you all on what I think is a really important topic, especially in our current day and age.
And about the book, Science versus Story. By the way, we have copies for all of the fellows after the session, and Emma will be available to sign your books. So please check that out. Be sure you get a chance to pick up your copy, and you can get it signed if you'd like. The book itself, Science versus Story, analyzes 4 scientific controversies: climate change, evolution, vaccination, and COVID-19 through the lens of storytelling. Instead of viewing stories as adversaries to scientific practices, Emma Frances Bloomfield demonstrates how storytelling is integral to science communication. Drawing from narrative theory and rhetorical studies, Science versus Story examines scientific stories and rival stories, including disingenuous rival stories that undermine scientific conclusions and produce productive rival stories that work to make science more inclusive. And so with that, I have lots of questions for Emma. So, Emma, first of all,
Yes.
Why did you write this book? Who is it for?
So I started thinking about this book after I finished writing my first book, which was about communication strategies for engaging climate skeptics, where I interviewed over 100 climate skeptics about their beliefs. And so many people who I spoke to, once I asked them questions about the environment, would immediately launch into a story, a childhood memory, a conversation they had with someone, something they saw in the media. And it occurred to me that stories are just a really rich way that people are understanding information. And this is, of course, validated in the literature. Lots of scholars through time have looked at the power of narratives to be persuasive and to engage people in information. But I found that there weren't a lot of practical, theory-based advice for folks out there who wanted to tell a story. We were being told, tell your story, engage with story, but what did we actually mean by that? What were we telling people to actually do or adjust their communication to make it more narrative-like? So I did a deep dive into narrative theory across a variety of disciplines, including my own, of communication studies, and wanted to develop a more practical tool that folks could use to evaluate existing stories or build their own stories in a way that was accessible and easier than just sort of, okay, I'm gonna tell a story now, right? What does that actually mean? What does that boil down to if we wanna define what a story really is and why is it engaging or meaningful to communicate scientific information in that form? So my primary audience is really all of you, scientists. I want scientists to feel more confident being science communicators, being able to leverage stories in your communication. But I also think of science communicators quite broadly. It could be scientists. It could be people who are science media experts, journalists. It could be everyday people who want to talk about science and want the tools, right, to do so effectively, especially, as I mentioned briefly, referred to in our current moment where there's so much misinformation out there about science.
And for you, how do you define science communication?
I break down science communication into two parts, which roughly refer to sort of the presence of scientific spaces or scientific experts. The first is internal science communication. So that's when scientists are talking to one another or operating in technical spaces. So I would think of this conference, right, as a type of internal science communication. External science communication is when scientists or experts, kind of leave those technical spaces and enter public arenas and talk to non-experts. Or external science communication might be just non-experts, right, talking to one another. So it could be internal, happening in scientific spaces, any kind of communication about a scientific topic, or it could be external to scientific spaces, people talking, right, about climate change, or people talking about COVID with friends and family or on social media is more of that external science communication. And the external part is what the book is largely focused on, though I think a lot of the storytelling strategies could still be useful in internal science communication situations as well.
So what are the common flaws when scientists start to try to communicate their work? I mean, what gets in the way of a scientist, who has a story to tell, reaching their audience?
I think some of the primary flaws stem from the fact that scientists tend to communicate to the public about their work in the same way they were trained to do science. So by that I mean scientists are oftentimes told to remove themselves from the study, right? We are sort of passive observers of a situation. We're not actively involved, and that helps to retain an element of objectivity and neutrality when we do work. But members of the public want to know who people are. They want to know interests and motivations and who's doing the research. So if scientists are communicating in the same way they're doing the science, they're missing, right, that human element that members of the public really want to engage with. I also think there's a tendency for scientists to look at the big picture. What are the big results? What are the larger meanings? How are all these things interconnected? But that can be outside the scope of a lot of people's understandings, right, of their day-to-day lives or how things work. So if you're focusing only on the big picture and not making it relevant to people's everyday lives, that can also lead to a misalignment in sort of the expectations the public has, right, about scientific information. And I talk about these misalignments in the book. Ways we think about scientists communicating internally with one another is not the way that public audiences expect to know and receive information.
So, one of the things that, I've run into over the course of my career is the scientist who says, oh, communicating, to the public is not my job. My job is to go do my research. So what, why are scientists an important part of this process? Because obviously there are people like me to do some of this work. What is the role of the scientist communicator specifically?
Well, first I would say that's right. Your job is to do the science, right? But I do think that scientists are super important science communicators because you know the science the best, right? And in your case, you have your PhD, right, in chemistry, so you know the science really well. But oftentimes science journalists, science mediators, go-betweens between those technical and public spaces are not going to have those same kind of credentials or be as experts in a topic as a scientist. So misunderstandings, mistranslation, miscommunication can occur. But if a scientist who knows, right, the most information about a topic does that translation and communication work, I think it's less likely for there to be mistranslation and misunderstandings. But then, of course, that puts a burden on scientists to learn more about different communication strategies. I do think that we want as many science communicators as we can, but scientists make for really strong communicators because of the closeness to the topic, your ability to talk about personal experiences, doing the research, being in these different situations.
You were talking earlier about the fact that good science communication, the external communication, involves sort of putting yourself into the, putting yourself as a scientist into the situation. That also can feel vulnerable. It can feel risky, and I'm wondering, particularly about where storytelling and narrative can help with that part of science communication.
Well, as a personal note, I experienced some of those risks myself. If you've ever been someone who's published online about anything or done an interview in the media, sometimes you can get some pretty hateful responses, comments, emails. Putting yourself out there on any topic, right, opens you up to potential vulnerability and feedback. But even presenting at a conference like this, you're opening yourself up, right, to critique, to questions, right, from your peers. So I think there's an inherent vulnerability and risk in any kind of communication. Sharing that work that is so personal to you, that you've put so much effort in, is a very vulnerable thing. But what I would say is I would encourage folks to kind of push through that vulnerability and think about, well, why does it make me vulnerable? Because it's really important, because people disagree with me, because there's misinformation, right, that's potentially clouding people's thoughts on this subject. So that makes it even more important, I think, for scientists to go out there and try and share better, more accurate information, because there's certainly people sharing scientific misinformation that don't have those same kind of worries about risk and vulnerability, right? They're sharing it quite rampantly. So my hope is that the book and then just science communication tools in general might help scientists feel more confident and able to take those risks in a more measured way. In terms of the last part of your question about can narratives help, I'm hoping that leaning into narratives can help give folks a standard form or format or structure, something to refer to as a starting place, right, for building those stories, so you're not starting from scratch.
So let's dive into some of that structure. So, in your book, you're talking about science stories within these wedges of different narrative features. So talk a little bit about those narrative features, what they are, and how that works.
Yes, so I said in one of the answers to the first questions that I wanted to create a practical tool, right, to help scientists communicate. So I created this tool called a narrative web. And the narrative web has, here it is, sorry. The narrative web has 6 different wedges on it that each refer to a different narrative feature. So in my deep dive into narrative theory across disciplines, I categorized the most common features that were in people's definitions of stories, and these were the 6 most common. So people talked about characters, they talked about action, or you might call it plot, sequence, and scope, the storyteller, and then the content. So I wanted to assign each of those features to a different place on this map that you could then use to build out these different features within your communication. So as I mentioned, each of the features has a wedge, and then there are 3 rings, the micro ring, the meso ring, and the macro ring. On the micro ring, the feature in the story is really concrete and specific. And then as you move farther out to the macro level, the feature is either not present or it's really abstract or broad and generalizable. So the idea is that if you were to analyze a story or you could build a story, you would try to map each of the features onto the 3 rings, and you would create what I call a narrative constellation, right? So in this image we have here, we have character and scope mapped on the macro ring. So that means that the character is really broad and abstract, or maybe there isn't even a character present. If you're just talking about molecules or atoms interacting, there's really not characters for people to engage with. That would be a macro level character. A macro level scope might be talking about billions of years into the past in the story of evolution, right? And then action, sequence, and content in this example are on the meso ring. So those are more middling levels of specificity and concreteness. And then in this case, the storyteller is on the micro ring. So maybe the storyteller is someone specific and known and trusted by the audience, which means they would be mapped on the micro ring. So the idea is that you can map these different features, and it gives you a sense of how specific and concrete and relevant your information is to your audience, as opposed to what science communication or what science would generally have as a more macro level story, which would be maybe too broad or too abstract or too complex for public audiences to understand.
So one of the things, one of the big points I remember from your book and sort of talking about these constellations was, was this mixture of levels. And can you talk a little bit about, kind of, I guess, the secret recipe involved in, different places on the ring versus different wedges, and kind of, the combinations that people might need to think about when they're trying to craft a good story?
Yeah, it's a really great question. So the general conclusion of my book, after doing a lot of close textual analysis of scientific communication from scientific institutions versus who I call rival storytellers, which tend to be folks who are spreading scientific misinformation, is that science stories tend to be macro level stories with almost everything on the macro ring of the web, whereas rival storytellers tend to cluster around the micro ring and give really specific, examples and relevant information. So my sort of formula or recipe for the narrative web is I encourage folks to have at least 2 features mapped on the micro ring to give audiences something to hold onto while not compromising scientific information. So by that, I mean, if you have everything on the micro ring, maybe you're not giving the full scope, right, of your scientific topic or its history or its importance. So you don't want to put everything on the micro ring, don't want to overemphasize the micro, because then you lose a lot of what's amazing about science. But if you don't have anything on the micro ring, you don't have anything for the audience really to hold on to or find relevant to their everyday lives. So I say in the book, try to have at least 2 on the micro ring, and then experiment with the other features to make it a really dynamic and engaging story.
And I guess, I think it could be really useful to maybe talk about a couple examples. Either things, and maybe the best thing would be an example of, a story done well, or a case study of some kind that you think is particularly a good illustration.
One that I really like that I talk about in the book is Congresswoman Alexandria Ocasio-Cortez created a YouTube video called A Message from the Future, and it's a translation of the Green New Deal bill. So instead of asking people to read the highly genred political text, she created this video that gives you insight into what the bill contains, but in a narrative format. So the video follows Alexandria Ocasio-Cortez as an older woman reflecting on the world since we passed the Green New Deal. We, of course, didn't, but it's sort of supposed to be this retrospective of if we had passed it, look at all these amazing things that would have happened. And it follows a young girl and sort of her growing up in this Green New Deal era. So for me, it was a really engaging way to turn this highly technical policy document into the narrative of a young girl, and then using Ocasio-Cortez as the narrator reflecting on this past that for us might be our potential future. It's something I talk about in the book because I think was a really well done narrative. You might be familiar with the film Don't Look Up. And I think there's lots of potential flaws we could talk about in that film, but something I really like about it is it takes this really intangible, diffuse concept of climate change and transforms it into a meteor, right? So everyone understands that a meteor is a threat, it's a risk, and we have to pay attention to it right now. So through the use of metaphor, really collapses this intangible macro scope, right, kind of concept, and makes it more accessible for people to understand. So those are two examples I talk about in the book. Mm-hmm.
And in the broader sense, how do you think, how can scientists sort of take this, take these tools and apply them, craft them? I mean, obviously, every story is different, every scientist is different.
Mm-hmm.
But what are kind of your key bullet points of advice for people who are saying, okay, I have this story I want to tell. How do I figure out how I want to tell it that's going to be the most powerful and impactful?
I think what you said is really important, that every story is going to be different. All stories are going to be context, audience, and purpose dependent. So if you have some information you want to tell and you think you want to use a story, I would definitely reflect on what the purpose or the goal is in telling that information. So for example, if you really want someone to understand the long-term effects of your research, okay, so then you would think about the scope being at the macro level. So then what other features of the web could you manipulate to give the audience something more specific to hold on to? In terms of the risk and vulnerability question, if you aren't comfortable having yourself be a micro character, is there perhaps another scientist or someone in the affected community that you're studying who could be a micro character instead, right? For me, it's really a tool of experimentation for folks to have a place to start with to think about these different elements. I want scientists to reflect on how communication can be more story-like than the more stripped down, objective, neutral attempts to be kind of unbiased in science that might be really appropriate in a journal article, right, is not necessarily the appropriate way to think about how you would talk to publics about the same content.
And I want to take this, I mean, obviously your book is not looking at, say, the nuclear, the nuclear science space, mm-hmm. and, stewardship science. And obviously, I mean, a tricky part of science communication for people in this room is that some of this information is secret, right? Yeah. I mean, there's a genuine tension there. Mm-hmm. And you've done, and Emma's actually done some other work, looking at nuclear energy. So and we can share that with you later if you're interested. But are there things that you think are applicable from what you've learned from some of these other areas of science, or things that are unique to, say, the nuclear energy and nuclear security space?
That's a great question. And in the conclusion of my book, I talk about how I only focus on 4 controversies in the main text, but I do a mini narrative web analysis of 3 additional controversies, and nuclear energy is one of them, actually. So I do talk a little bit about how nuclear energy and controversies around it are similar in terms of concepts like uncertainty, right, and risk that people are really interested in knowing, similar to climate change, which is future-oriented, and we might not have all of the answers. Oftentimes, nuclear energy doesn't as well, and that can lead to uncertainty and confusion in audiences. There's also concerns specifically with nuclear energy waste, that might come up against rival stories from local communities or indigenous communities. So there's some competition there in terms of which kinds of stories are we adhering to or following, and what values are we really taking into consideration when we talk about nuclear energy. So I do think that there's every science controversy is different, every story is going to be different, but I do see definitely some threads of these same kind of issues in terms of how we communicate the science are still relevant, to nuclear energy. And in terms of things being secret and you can't talk about them, that is I think a consideration, for example, if you're being interviewed or you want to write a story, think about what you can talk about. Don't focus on what you can't talk about. And think about crafting a story about the knowledge that is going to be accessible or that you can talk about in more detail. So for example, if you can't talk about the present, what you're doing, maybe you could talk about how you got involved in this research, or maybe what you want the future of this research to look like. And so you don't have to talk about details of the present moment, for example.
How are we doing on time? Because I just want to get a sense of where we are within the session. It's 2:45. So we are just about at a half hour. You want to go ahead and transition to the?
Sure.
Okay. So we are going to transition to an interactive activity and a chance for you to kind of think about some statements and sort of discuss amongst yourselves. And I'm going to let Emma, take the lead in, taking that from here.